Today we're looking at finding the equation of a parabola. You will find in many other graphs that you do that you will need to also find the equation of that particular graph and not only know how to sketch it and also interpret questions from it. Let's quickly look at the standard forms of a parabola graph, because this is important. Whenever you're finding equations, they form part of the basis and the foundation of finding the equation of that particular graph. In grade 10, you learned about basic parabola graphs. Y is equal to ax squared. That's a graph that is not shifted. Y is equal to x squared plus q. Now the value of q is a vertical shifting of the graph. In grade 11, the standard form of a parabola graph is given as y is equal to ax squared plus bx plus c. Now, it is only that standard form that we play around with, because now the graph shifts sideways. So if we complete the square on that standard form, that's what we get, where the value of p indicates the horizontal shifting of the graph and the value of q still indicates the vertical shifting of the graph. If we factorize the same standard form of y is equal to ax squared plus bx plus c, we end up with a standard form that allows us to see the x-intercepts of your graph, that is your x1 and x2. Now these are very important because in finding the equation of your parabola graph, these come in handy. Let's look at an example. It says determine the equation of the following graph. We're given the turning point with coordinates 2 and 3, and also given a point on the graph with coordinates 4 and -1. Now clearly, because we're given a turning point, that is the standard form that will be suitable. We immediately substitute the x and the y coordinate of the turning point. Remember, the x coordinate of your turning point is the value for p, and the y coordinate of the turning point is the value for q, as you can see in our substitution. The next thing is always to substitute an extra point somewhere else on the graph, where there we can see the x is 4 and the y is -1. The only thing we're left with now is to solve and find the value for a. Simplify, ultimately get that, and your a is equal to -1. Now really it's pretty easy, and make sense of your answer for a. If your a is positive and yet you've got a graph that is facing down, that would be wrong. Surely somewhere there's an error in terms of your signs, so you need to double check. But if your a is negative and also the graph is facing down, then you know you're on the right track in terms of linking it to the graph. Now it's all about now substituting in that step where the only thing missing is the value for a. And if the question had asked you to write it in the standard form ax squared plus bx plus c, you would then multiply out and eventually end up with the standard form as requested. Okay. But there is always clear, indication in the question as to in what form you might need to present your answer. Let's look at this second one. If you look at the second question here, we've got intercepts given at -1 and 3, and then an extra point given somewhere else on the graph. Now clearly, here the standard form with the x-intercepts comes in handy, because then we'll be able to substitute our x-intercepts and then substitute the coordinates of the extra point, which is exactly what we've done there, substituting the x as -1 and y and x as 3. Now have a look carefully that our standard form had x minus x2, and here we end up with x plus 1 because the x-intercept we're substituting is negative. That's why we ended up with an x plus 1 there. Always watch out for those silly errors that might come in during your calculations. Then we're now left with substituting our x and y coordinate from our extra point given on the graph, and that is pretty easy. All that is left now is just to simplify and solve for a in the equation, and in this case our a is equal to 1 and yes is positive. The value of a is showing us that the graph is facing up, as we can see on the sketch. Now again, it's all about now going back to that step, because at this step this is the only thing missing, the value for a, and you substitute a as 1, multiply out, and then our equation is in the form ax squared plus bx plus c. Okay, so pretty easy. Always watch out for those things that will assist you, but what is crucial and important here is always about the standard form that you would use as the building block for your equation. So you have to be really observant in your graph and see what has been given or what is available.